We are going to solve this problem, surrounding regions. It's basically like an island problem. You are given a board containing X and O. Capture all regions that are 4 directions surrounded by X. For this example, the surrounded island should be like this 3. Then eventually we will transfer to this one. I will try to solve this problem in 2 ways. First way is to leverage the island stuff. So I will go from the edges to flat fill everything connected to the 4 edges, then determine which connected with this anyone connected to the edges will be marked a special character. Later we will go through the board. If we encounter still we have the initial O's, we will flip the O to X, and at the very end we will flip all the special characters to back to O using flat fields. Okay, so the idea is to find flat fill or 4 edges connected island, mark as special character, for example this one, and loop or O, flip to X, flip this one back to O. Okay, so first let's do this one, dimension for not this. Let's do trace, define a DFS. Oh, if the board, the row and the first column it's char O, we do the flat fill DFS. Also, if the last column it's O, so we also do the flat fill. This is for all the columns, left and right. I mean, do the same thing for all the columns. Oh, we can combine together. Okay, if the first row and the column is O, or the last row and the column is O, we do the flat fill. Now I loop all the thing. If the is still the O, I will modify this one into X. If the board is marked this one, we need to transfer this guy back to the initial O. Okay, now it's time to define the flood view. Here first we have board to index. If outer bound outer bound we directly return a stop search, and if it's already X, we're not interested in X. We also stop search. Or we already visited. In these two cases, we are not interested here. Otherwise, we marked this special character and DFS for adjacent directions. And I think that's it. Let me try to run it. Cannot find the symbol. Okay, we have no J here, so we're directly using the 0 -1. This 0 I. Okay. To split two cases since the parameters are not the same. And the last row and this column. Okay. Does this complain? Let me try right. It seems it works. Let me submit. Yeah, it works. Start to analyze the time and space complexity. So the time, this is the loop to mark to do the DFS mark every adjacent to the 4 edges to the special character, and in this case the DFS each node will be traversed at most once, so the total time complexity will be O of dimension of the input m multiply n. The space complexity, we build anything additional data structure. This is the input data, the input array, 2D array, and the space will be the core stack. We run the DFS, we will use the core stack using some space here, so the space will still be the mn to use up. In the worst case, it will to these steps all the time. Let me verify about the time and the space. Here of n number of cells in the board, space of n. Choose place consumes this additional memory. Let's see what's it. List of border cells starting point for traverse. Consider the number of border cells proportion to the total. What does that mean? The border recursive core consumes some space. Core stack. Okay. Would pile up along with the depth of recursive core, and the maximum depth of recursive core would be n in the worst scenario. Worst scenario, what's the worst scenario? Contain only one cell on the board. Traverse each cell twice, once during the traverse, other time during the cell reverse in last steps. Okay, so literally it's the same. And let me try to solve it another way. The topic for today is unifying, so I will first to discard the change, try to use the unifying. It's a little overkill. The basic idea is to first to have the class unify, and in each one we are trying to have the dummy node and use that dummy node to unit every O cell to that unit to that dummy node. If and at the end anything related to the dummy node will be flip. If not, it stays the same. This is the basic idea. Let's check out it should mentioned in the answer. Oh no, so it's a little overkill, so and it's time consuming. I will not demonstrate here, and that's it for this question.